NASA didn't spend billions on two space telescopes by accident. The James Webb Space Telescope is already showing the first galaxies in the universe. So why launch another observatory that looks completely different? Here's the twist. Webb isn't being replaced. It is so good at zooming in, we built a second telescope to see everything it misses. Imagine studying a single leaf, but yet you're missing the entire forest. Webb gives us the deepest close-ups in cosmic history. The Nancy Grace Roman Space Telescope zooms out, capturing a view of the universe up to 100 times wider. Because to truly understand the cosmos, you don't just need a sharper eye, you need a wider one. One telescope shows us the first galaxies ever formed, and the other might reveal entire new worlds we've never seen before. Webb and Roman look completely different for a reason. They're built to do completely different things. Webb is all about sensitivity. Its massive 21-foot mirror collects light from the faintest, most distant galaxies. Those galaxies are so far away, their light has stretched into infrared wavelengths, a process called redshift. Webb is tuned to see that stretched light, so it peers deeper into the early universe than any telescope before. But to detect that faint infrared glow, Webb has to stay brutally cold. Roman takes a completely different approach. It doesn't need to see quite as deep because it isn't chasing the very first galaxies. So, Roman can work with a way smaller mirror and far less cooling. The shade from its solar panels does most of the job. If Webb stares incredibly deep, Roman is optimized for something else, called field of view. Roman's wide field camera uses 18 advanced detectors to capture an area of the sky about 100 times larger than Webb, while still resolving individual galaxies. Instead of studying these galaxies one by one, Roman maps entire cosmic structures, clusters, filaments, and the dark matter holding them together. But how do you turn that massive view into real discoveries about the universe? And that's where Roman starts to change everything. Roman's wide view and Webb's sharp vision aren't just for galaxies. They're perfect for hunting worlds. Think of the universe as a city at night. Galaxies are the skyline and exoplanets are the lit windows. Roman's job is to find more of those windows. Some of the planet it finds won't orbit any star at all. Like Kepler and TESS, it will detect planets when they dim their stars. With its huge survey area, Roman should catch thousands. But its real superpower is gravitational microlensing. Gravity itself becomes the lens. When one star drifts in front of another, its gravity briefly magnifies the background light. If a planet is there, it adds a tiny extra bump. These events are rare and short, but Roman's constant wide monitoring gives it a real chance to catch them. Even rogue planets, drifting through space with no star at all. Roman will also test a coronagraph to directly image giant planets around nearby stars. Then Webb steps in. Roman finds the worlds, Webb studies what they're made of. That's the real power of these telescopes. One discovers, the other reveals. And they're not competing at all. They were designed to work together. For the first time in history, two giant space telescopes will explore the universe side by side. Roman finds the worlds, Webb will reveal what they really like. Together they tackle the biggest question we can ask. Where do we come from? And are we alone? No single telescope can do everything. That's why NASA designed them as part of a team. Webb and Roman will share the same neighborhood in space, the Sun-Earth L2 point, about 1 million miles from Earth. Out there, gravity balances just enough to keep both telescopes in step with Earth while they orbit the Sun. Out there, 1 million miles from Earth, two telescopes are about to rewrite what we know about the universe. And this is just the beginning. If you want to follow the discoveries Webb and Roman will make next, stay with XOVION as we explore them, one story at a time. And as always, thank you so much for watching, and I'll see you in the next one.